We're going to run through an Hpt logging process today. This is Ben Jaster. Ben is one of the engineers in the Geoprobe direct image department. I'm Wes McCall, a geologist with Geoprobe. So we'll look at the hydraulic profiling tool and running a log. On the lower end of the probe, we have 4 electrodes that are isolated by an engineering plastic. This is our electrical conductivity array. It is a winner array, so we get an electric log from this. Further up on the probe, we have our Hpt screen. This is a wire mesh screen, and it's replaceable, so if the screen gets damaged in the field, you can take it out and replace it. Okay, so we inject water through the screen as we're advancing the probe at about 2 centimeters a second to get our pressure log, and we'll also get flow data. So we get an EC log, pressure, and flow data with the Hpt tool. So of course we have our computer with the software in the computer. Then we have our field instrument. This is the FI 6000 field instrument. This is like our analog to digital inverter here. So it takes the analog data from the EC array, the pressure sensor, and our string pot, and changes that to digital to plot on the computer. Our Hpt Flow Module here provides us with a pump for flow. There's a flow meter inside that shows us the flow rate if we're injecting the water into the formation. Okay. We also have an on-off valve for flow, so we can stop and do a dissipation test, which we should do later. And then we have a flow adjustment, so we can adjust our flow rate. And we typically run between 200, 300 mils per minute flow when we're running the Hpt probe. In the software here, it allows us to choose the tool, the probe we're running. This is a KS6050 Hpt probe. It also will allow us to enter calibration for our Hpt transducer. So this Hpt transducer is our pressure transducer, and each pressure transducer has a serial number and a calibration sheet that gives you the calibration curve and the data to enter into the software when you install a new pressure transducer. And the pressure transducer sits in the connection tube here just above the probe. So now we'll just work through the software here. We have our pressure transducer already entered. And we'll start off with our electrical conductivity test. This is the test jig for the EC. You see we have 5 electrodes on this, springs, and those will attach to each of the electrodes and one to the body of the probe. The body is the ground for the EC array. Ben will go ahead and install that there. And there are magnets on that to help hold it on the probe. And then we have our test load here. Okay, Ben, you're going to run through the test load. We'll start with 1. And you can see the EC should be around 195 millisiemens per meter with that. And I mouse over and click on run. It'll count down for 5 seconds. And then collects the data, and that we pass on the first test and the second test. We should be about 97 millisiemens per meter with this. Looks like we're very close there. Okay, and our third test is the low. We should be around 24 millisiemens per meter. And again, pretty close there, just below 24. So our EC test all pass. So our EC array and the EC system in the electronics is working. And we're back to our Hpt test. We'll turn our flow on and let water start flowing out the screen. Okay, so you can see, maybe you can see that we have water flowing out the screen, and I'll put a little pressure on it and you can see the water kind of jet out. And usually we'll run the trunk line when we first start up a few minutes to let it purge air out of the system, and I kind of pressurize the screen 2 or 3 times during this process to help kind of burp the air bubbles out of the system here. So it seems we have pretty good response. We'll go ahead and put this guy in the reference tube, and you can see the valve here is open, water flowing out, and the top of the reference tube is 6 inches above the valve. So what we'll do, we'll measure pressure at bottom with flow and the top with flow, and then we'll do a pressure measurement without flow. That will be our real QA test. So we'll pressure at top and bottom, and we'll see if we can accurately measure the pressure for 6 inches of water head. Okay, so now with flow going, look on the screen, we're running about 14.9 psi and around 255 mils per minute. We capture that. Okay, now Ben will close the valve and add some water and top it off here. Okay, and now we'll get our measurement at top. So about 15.14, just over 2.2 psi. That's very nice. Okay, so now we'll turn off the pump and stop flow and close the valve so we don't have spurious water flow through the line. So now we'll make the measurement at top here with no flow. We capture that, and then now we'll open up the valve and go to bottom. Okay, let that drain out. And stabilized here pretty good, 14.73 capture and 0.212. We pass our QA test. So now we'll go and set up over at the probe. Okay, to measure depth while we're advancing the probe, we use a string pot, and the string pot will attach to the hook on the mast here. So as the mast is lowered, the length of the string changes, and that actuates the transducer in the string pot. There's a string potentiometer, and sends a signal through the cable to the instruments on the truck to let us know what depth we're at. So at each 0.05 feet, or about 15 millimeters, we log a pressure and flow and the EC value as we advance the tool. So I'm simply going to place the string pot on the ground and attach the string with a little clip here, so we are set up to measure depth as we advance the tool. In a minute we'll level this up, but Ben reminded me I need to talk about health and safety while we're running the probe machine. So as you can see, we have hard hats, safety glasses, hearing protection, gloves, and steel toe boots. Thanks for reminding me, Ben. So use appropriate health and safety equipment for the job site you're working at. Okay, so now a couple of things here. Ben has attached the slotted drive cap on the probe, and this slotted drive cap slides over and allows the trunk line to come out so we can advance the probe without damaging the trunk line. And now we'll kind of level up the probe unit and then get the HPT probe set up underneath. Okay, Ben, go ahead. It's really helpful to level up the probe, make sure the probe is plumb, so it's much easier driving, and then it's also much easier recovering the tools. And you'll notice we have the rod wiper on the ground here, and we'll use that when we pull the tools out to remove mud and goo from the probe rods, so the tools come out kind of clean. We don't have a lot of cleanup work to do. The rod wiper is really nice. Now I've got to turn flow on, so I trip on the valve and turn on our flow. And Ben is going to advance the probe where the screen is at the ground surface. Whoa, there we go. Now we're at ground surface. So now on screen on the computer, we've zeroed up the probe at depth. Ben is ready, so now I click on the trigger standby, and goes to trigger logging. So now we're ready to acquire data. So Ben will now advance the probe at about 2 centimeters a second. And we can begin to see data come up on the screen. We have our EC and depth on the left, and then our Hpt pressure and our Hpt flow. So you can see that trunk line management is a part of the process. We'll snug up the rods. Okay, pretty good. Now we'll just continue driving until we get to a depth where we want a dissipation test, and then we'll stop and run a dissipation test. Okay, so now we're at 33.7 foot depth, and you can see our Hpt pressure has been pretty high up until over 26, 27 feet, and it started to drop down. And you can see the EC array is a little deeper than the Hpt probe, and it's just over 34 feet, and the EC is pretty low and flat. And with the Hpt screen is at 33.7 feet, and so the pressure has dropped and kind of flattened out there. So what we'll do now is we'll run a pressure dissipation test. So I'll change screens. I'll go to our time file, okay, and then I'll go and click on dissipation test. So run dissipation test, and here you can see the screen color change from gray to white, and you'll see our Hpt pressure, Hpt flow, and our line pressure. So now I'm going to turn off the pump to stop flow, and you can see our flow and pressure is dropping here. I'm going to try to adjust our scale on our pressure graph so we can see that a little better. Okay, so now you can see the pressure in the top graph has dropped down and is starting to level off. It looks like the pressure there is about 21.3 psi. So we have a nice dissipation test and a good permeable zone of the formation. So our dissipation test is pretty much complete. So we can turn our pump back on, open up our valve, and our flow and pressure returns. Okay, so we let flow and pressure come up, and we end our dissipation test here. You see the screen goes back to gray, and then we go back to our depth screen, which shows our log. Okay, so we're now a little over 60 feet, about 61 feet on the electrical conductivity log. So we've run into the shale and gotten refusal at the shale bedrock here at, as I said, just over 60 feet. So now we'll disconnect the string pot and get it out of the way. We stopped the log on the software. We stopped that. So what we'll do now, we have the rod wiper on here. So we're at the weldment to hold the rod wiper in place. Okay, and now we'll put the rod grip handle on, and the rod grip grabs the rod and the jaw on the probe, on the hammer here, and we'll trip the tools out slowly. We got to make sure we have our Hpt flow on. We have flow while we're pulling so we don't clog up the screen with clay or silt. And there we go. So now we have the probe out. Maybe you can see water is still flowing out the port. And we'll clean up and run our post-log QA test. I just want to mention now, to complete the project here, we'd probably want to go back in and do pressure grouting to grout up the borehole, especially if we have any contaminations, especially if we have DNAPLs in the ground. So you can re-enter with a second tool string, expendable point, and we have a grout machine and a grout hose, so you can pump grout through the rods and pressure grout and seal the boring up. Okay, so now we've got the probe out of the ground and we've wiped the worst of the mud off of it. So we're ready to do our post-log quality assurance testing. So first we would do the EC test with our test jig and test load here. And so in our post-log QA, we'll do the EC first, and then we'll go back through the HPT reference test. We'll turn our flow back on, go in the reference tube, rerun that post-log reference test to verify everything is still working properly when we completed the log. And then we can review the log on screen during the webinar and talk more about interpreting the log and look at the dissipation test and discuss the piezometric profile and our piezometric surface using our dissipation test data.